3 under lecture 2, we have this expression. This time, we are using or nor to do your expression. So, first, we have to let this as your x. It is or with your, we have to call this one as y. And it is or with your third term, we call this one as your w. So since it is your y, it is equals to x or y or w. But we are using nor, so we have a long bar. So if this is a long bar between your x or y or w, if we have to break the bar between the variable, it will become an and. So we are not going to break the bar using Boolean, but we have to add another long bar. Using double negative, it will back to your original expression as x or y or w. So first, what is x? So your x is equals to b bar c bar. But we are going to use nor. So in your nor, if this is your b, nor c. So it is a nor. But if you have to break that bar, because we are using a nor, we have to break that bar, it will back to its original expression. And for your y, so in your y, it is equivalent to e bar b. Using a nor, we have a nor b. Using a nor. So if you have to break the bar, it will become e bar, then b bar. So we have a bar in your b, but your original expression, there is no bar in your b. So we have to add a bar in your b with that nor. So this now will become double bar. So using a Boolean identities, it will now become a b. For your w, it is equals to a, then we have b bar and c. If we have to use a nor, that is a nor b, a nor c. So it is a nor. Using Boolean algebra under De Morgan's theorem, it will become e bar, b bar, and c bar. But in your original expression, e and c has no bar. So to eliminate this bar between your e and c, so we have to introduce a bar in your nor input as well as a bar in your c. So we have e bar and c bar. So your y, if you have now to rewrite this in terms of your x that we have simplified. So we have b is nor with c. So we have to open and close that one. Then it was with an or sign with your y. Your y is equals to a or is b bar. and it is OR with your third term. It is E bar or B or C bar. So we have a bar. Then we have this one. It is a NOR, and we have to complement or put a bar in the output of your NOR so that we can get out that double bar. So our first input is B NOR C. So we have to draw NOR gate with input B and C. So this is NOR. Remember, in your NOR gate, your input side it is a curve, whereas in your AND gate, the input side is a straight line. So we have your B and this is your C. So we have B input and this is your C. Remember that this is a bar in your B. Then we have to draw a complement for your B. This one. So this is OR gate. So NOR gate. This from your B. And it is connected. Remember, this is a NOR. It is connected with your A. So we have another NOR. We have input A. And this is your input B. So this one is your X. And this one is your Y. In the third term, we have your E bar. So we have a NOR gate. With connected input that is from your A. Then we have another NOR gate. And this one is from your C. And it is connected with a 3-input NOR. So we have NOR. This is A bar. And we have your B. So this is your B. We have your C bar. So this is your W. We are connected with a NOR. We have your X, your Y, and your W. And the output of your NOR is also inverted using all NOR. And that is your Y. So this is the circuit using all NOR.